Hi students, now let us solve question number 7, JEE. So in the seventh question, they are saying two springs with negligible mass, so meaning ideal springs with force constants K1 200 Newton per meter, this is K2 160 Newton per meter, are attached to the block of mass small m in this fashion. Okay. Initially the block is at rest here at equilibrium. So these two springs are neither stretched nor compressed, in which both the springs are neither stretched nor compressed. Obviously, that's what I was saying. Equilibrium means net force should be zero, so this block should not feel any any spring force from either side. So there should not be any stretch or compression in any one of the springs. At time zero, a sharp impulse. So at time zero, a sharp impulse is provided, and the magnitude of the impulse is given 15 Newton second. 15 Newton second. With a hammer along the spring. So at this top we have given some impulse. So they are asking us to check for option A, period of oscillation of mass m, maximum velocity of mass m. Data is insufficient to find maximum velocity, and last option is amplitude of the oscillation. So first of all, realize that these two springs are actually in parallel. You can redraw this diagram as this block. Two ends of the spring are connected to the block, right? So two ends of the spring are connected to the block. Other two ends are connected to the wall. So you can consider this to be the wall, right? So if you push this way, then both will exert spring force this way, right? Both the springs. Here also, if you push it this way, this spring will get compressed, so spring force will be this side. This spring will get stretched this way, right? So spring force will be this side, exactly in this fashion. So these two springs are in parallel, so your effective spring constant will be K1 plus K2. That will be 360. Once you know the effective spring constant, the period of oscillation will be what? 2 pi root over m by K effective. So 2 pi root over mass of the block is 10 kg, K effective is 360. So 0 will cancel. This will be 2 pi by 6, which will be pi by 3 seconds, which is approximately 1 second. So they have given pi by 6. So the first option that they have given is wrong. Second option is maximum velocity of the mass during its oscillation is 10 meter per second. Now at this point you have given some velocity, right? How? Because you have applied this much impulse. So that impulse will make the body start with some velocity here only, because it is impulse. Impulse means force acting for a very short interval of time. So how much velocity it has here, that itself will be the maximum velocity. Why? This is going to perform SHM about this position, and that position is your mean position. And at mean position, whatever velocity it has, that is your maximum velocity. So we need to find velocity with which it starts. Initially it was at 0 speed. So impulse is change in momentum. So m final minus m initial. So impulse was mentioned to be how much? It was 50, I think. Yes. So impulse is 50, mass is 10. Final velocity is the velocity with which it starts here itself, okay? Because it is impulse, again I'm telling you. Initially it was at rest, so this is 0. So final velocity with which it starts is 5 meter per second. That itself is your maximum velocity, which in the option they have mentioned it to be 10. So option B is also wrong. Option C is obviously wrong. They told data is insufficient. But as you can see, the data was very much sufficient, right? The next thing is to find the amplitude. So once you know this is the maximum velocity, how is maximum velocity in SHM related to amplitude? So this is A omega. See, the whole point of doing SHM was what? You get all this small useful formulae, so that you don't have to again run through conservation of energy and find the spring potential energy is converted to kinetic energy. All those things we don't have to do now. Okay. So maximum velocity is 5. Amplitude we have to find omega of this spring. So omega let us calculate. I think omega we calculated it. So omega is root over K by mass of the system, okay, omega is it's root over K by, time period is 2 pi root over m by K, right? So K effective was how much here? K1 plus K2 in parallel. So this is 360 and this is 10. So omega is 6. So omega is 6. A will be 5 divided by 6. Right? So 5 divided by 6 will come 0.83 meter. So option D is correct. Let's see the next question now. Two blocks of mass M1, M2 are kept on a smooth horizontal table as shown in the figure. Block of mass M1 but not M2 is fastened to the spring. So only one block is fastened to the spring, other block is not fastened. So what they will do now is, the block which is not fastened to the spring, they'll bring it, if now both the blocks are pushed to the left so that the spring is compressed at distance D. So here is the spring, here is the block which is connected to the spring, other one is not connected because it's not fastened. So this is your M1. But then this is put here and then the whole thing is compressed by a distance of D. The amplitude of oscillation of block of mass M1, because this is fastened, right? So this will go off. You will see now after the system is released. So what will happen after the system is released? So this whole thing will be compressed here. Then while coming back, this too will have a certain velocity right here. Yes or no? So it has been compressed here, here, till here, and then you release it. So from here to here, as it comes, the potential energy which was stored here, okay, that is half k d square. That will go into the kinetic energy of these two blocks. Both of them will have, because both of them are moving together. So half m1 plus m2 into v square. So your half gets cancelled. So v will be equals to root of k by m1 plus m2 times d. So this itself would be the question, right? To find the velocity with which this m2 will shoot off. So once it comes here, then see, then the moment these two blocks tries to go this way, this will feel a restoring force this way. This will not, because it is not fastened to the spring, neither is connected to, attached to this block. No, some fevicol has not been attached, right? So this will continue with v speed, but this will slow down because it will feel a spring force once it goes beyond this mean position, right? It will feel a spring force this side. So this will slow down, this will continue to move with v, so this will get out. So now this will start oscillating simple harmonically, and this will be the what position? Mean position, right? Horizontal SHM it is with the spring. So this will be the mean position, at which point this is the velocity. So this is the velocity of this n1 at its mean position when it comes back here, and thereafter it performs SHM. So if this is the velocity at mean position, this must be your maximum velocity, and that must be a times omega. So root over k by m1 plus m2 d equals to a omega. Now what is omega? Now only this block is oscillating, right? Not this one. Once it leaves. So omega will be root over k by m1. So root k will cancel. Amplitude will be root of m1 by m1 plus m2 times d. Okay? Root of m1 plus by m2 times d. So which is the right option? Option A. Let's